All right, hi everybody. So today is going to be a review day over sections 5.1 to 5.3 and all of the factoring materials that we've had for the choice board. Now, for those of you who have not gotten all of your assignments done, today might be a little bit busy of a day. For those of you who have everything done and are just kind of like just waiting on the review assignments, I know a lot of people have posted or submitted your assignments, which is great. So let's talk about the expectations for today. Okay, those of you who have everything done, this might be a little bit, slow of a day, and that's okay. We're okay with that. Okay, so the first thing that everybody should be doing is finishing all of the choice board stuff. Okay, you should make sure that you complete all the assignments. Make sure you don't forget about the Desmos. A lot of people have not gotten that Desmos assignment done. Make sure you're clicking on that link in the modules. Second thing, once you've finished all of that stuff, you need to check your answers. Okay. Now, how do you check your answers? Well, just about 2 minutes ago, and I'm saying this on Wednesday night, just about 2 minutes ago, I posted this in the modules. Now, let me go into student view so you can see exactly, so I can make sure that you're seeing exactly what I see. If I go into modules here, and I go all the way down to the bottom, let's get this all out of the way. I guess it can collapse all. Okay, so here's all the choice board materials, and then you'll see right here, this is the section 5.1 to 5.3 choice board submission. Make sure that you're submitting everything there, and I'll talk about that in a second, but right above it, you see 5.1 to 5.3 choice board keys. Okay, if I click on that, this is a link with all of the keys to all the assignments on it. Okay, and this should be an updated page of all of the keys. So what you're going to do now is you're going to go through and you're going to check all of your answers. Okay, that's one of your responsibilities today. Just go through and say like, okay, here's my projectile motion assignment. Just open this up, make sure I've got all of my answers. Done. Okay, good. Next one up, here's the page 338 key. Open it up, check all of my answers. Done. Perfect. Okay, so all of that should be here. Now, let me jump back. Okay, those choice board keys. So you should be checking your answers with all of those keys. The next thing that you should be doing is submitting your choice board stuff. Now, when you go to submit your choice board stuff, you're gonna submit it right to this assignment right here, section 5.1 to 5.3 choice board submissions. Now, I would like everything in this order, please. Okay, this is the order that it goes from left to right, top to bottom on the actual choice board. So please submit it in this order. It's easier for me to grade that way. Also, I'd like it as one document, not 6 separate images. So please either use Cam Scanner or the Notes app if you've got an iPhone and put it to your computer and put it in a Google Doc or whatever you need to do. I just want one thing. Don't send me 6 different JPEGs. Please send me one document, one PDF, however you'd like to submit it. Okay. So now the last thing that you should be doing is now at this point going through the review. Okay, going through the review. Now, what is that? Well, this is, I'm going to be going through the review here in a second. This is basically this document that you see on the screen right now. Where is that? That is right down here, this 5.1 to 5.3 review. I'm going to be posting this video, this link to this video in here, as well as link it back to my home page as well. But here's a blank review if you want to print it out or just have it up on the screen. What I would do is I would do all of these problems and then check my answers with this video. So if you'd like to do that right now, if you just want to like pause, get all of that stuff done, do all of these problems, then come back to this video and check your answers, that might be a good idea. But I'm also going to just have this review key posted here as well. So either way, if you just want to look at the key or if you want to see the explanation through video, I'm going to be doing it here in a second, okay? So that's what you've got to do today. Once you're all done with that, that's pretty much it for the day. Remember, the individual quiz is tomorrow. The section 5.1 to 5.3 quiz is tomorrow. Okay, here we go. So a soccer ball is kicked from ground level with an initial vertical velocity of 32 feet per second. After how many seconds will the ball hit the ground, and what is the maximum height of that ball? Okay, so I know my formula is negative 16 t squared plus v sub 0 t plus h sub 0, where t is time, v sub 0 is my initial vertical velocity, and h sub 0 is my initial height. So in this case, v naught or v sub 0 is 32. H naught or h sub 0, well, since it's kicked from ground level, it's going to be 0. So I have negative 16 t squared plus 32t plus 0. That's going to be equal to h of t, the height, whenever I want it at time t. Okay, so it says after how many seconds will the ball hit the ground? Well, think about it. If it's going to hit the ground, it's going to hit the ground at height 0. So this is what I'm looking for here. I'm looking for the zeros of the function, the roots of the equation. So let's factor it, because that's the only way we know how to solve this right now. Let's factor out a negative 16t. We're left with a t minus 2 after we factor out the negative 16. So we have negative 16t equals 0 and t minus 2 equals 0. We divide over the negative 16t, or sorry, just negative 16, we get t equals 0. We add over the 2, t equals 2. So that means when is the ball when is the ball at ground level? It's at ground level at time 0, then again at time 2. So therefore we can say 2 seconds. Okay. Now what is the max height of that ball? Well, max height is a different story. Remember, this is the shape of the height, right, of the path. So the maximum height is going to be the vertex. Remember, the vertex, right? The vertex is that negative b over 2a, and then I plug it in, right? So let's figure out what, because this is the axis of symmetry, this is going to give me the t equals, or the time equals that value, negative b over 2a, because it's usually x equals, right? But this case is t. So let's plug it in. B is 32 divided by 2 times negative 16. Okay, well, that's easy here. Negative 32 over negative 32 is 1. So that means this apex point, this vertex point, is happening at 1 second. And at what height is that happening? Well, I just have to run 1 through. I've got to find h of 1 through the equation, right? So negative 16 times 1 squared plus 32 times 1. So that gives me a negative 16 plus 32, so 16. What does that mean? That means 16 feet is the true maximum height. When does that height occur? That height occurs at 1 second, which makes sense. You know, if it's starting at ground level and its total height in air is 2 seconds, half of that would be its maximum height, so 1 second. And the only reason that fact is true is because I started at ground level. If I put that anywhere up off the ground, then that whole half thing kind of goes away. But yeah, the rule about finding the negative b over 2a, that doesn't matter if I put it above, if I don't kick it from ground level or something like that, that I can always use this negative b over 2a. All right. Okay, using the graph as a guide, describe the transformation. So this is going all the way back to section 5.1. So what are the two transformations that I see going on right here? Okay, this is kind of in vertex form. That means that I've got a left 2 and then a down 4. Right? This is a minus 4, so down 4. That this is actually inside the parentheses, it's going to go left or right. So this is actually going to go left 2. Okay. I see 2 things, actually 3 things happening here. Okay. The negative 4, well, the negative on the outside means it's a reflection over the x-axis. The 4 means that it's going to be a vertical stretch, vertical because it's on the outside of the parentheses, vertical stretch by 4. Remember, if it was on the inside of parentheses, it would be a horizontal stretch or compression, and then I'd have to do that funky 1 over b thing. And then this is minus 1 is actually moving it to the right unit. You know, just to kind of reiterate that, maybe we didn't catch that. You know what, let me just see if it's vertical, horizontal. Okay, so I am going to do a horizontal down there. I'll just talk about it down there. Use the description to rewrite each equation vertex form. So vertex form is let's call it g of x. G of x is equal to a times x minus h squared plus k. Remember, the a is any vertical stretch or compression as well as any vertical reflection over the x-axis, which we saw in that -4. This is your movement left or right, and this is your movement up or down. All right, so if it's vertically stretched by a factor of 9, that means my a value is 9. Translated 2 units to the left. X plus 2 squared. So let's call it g. Why not? Okay. And then there's no plus or minus 0 out there. Okay, let's take a look at the next one. X squared is reflected across the x-axis and translated 4 units up. Okay, so negative x squared plus 4. There's my g. Negative on the outside because it's a reflection across the x-axis. 4 units up, just as a plus 4 on the end. Horizontal stretch by a factor of 5. Okay, so remember, horizontal stretch by a factor of 5. Remember that that's the f of x maps to f of 1 over bx, right? Okay, so that means if my b value is 5, it's going to be 1/5 x inside parentheses, then squared. Okay, and then we move it 3 units down, so minus 3. So there's g. That's my answer. Okay. For each function, determine whether it opens upward or downward, find the axis of symmetry, find the vertex, find the y-intercept, and then graph. All right, so first part here, A, determine whether it opens upward or downward. Since A is positive up here, it opens up. Part B, find the axis of symmetry. Remember, it's negative b over 2a. So x equals, and then we have negative 4 over 2 times 1, right? Because a is 1, b is negative 4, c is 3. So these negatives will cancel. 4 divided by 2 is 2. So the axis of symmetry is x equals 2. Remember, it's a line. Make sure you write the x equals. The vertex is 2 comma something. We get that 2 straight from here. And now we run that 2 through the equation. 2 squared minus 4 times 2 plus 3. Okay, that gives me 4 minus 8 plus 3. So negative 4 plus 3 is a negative 1. Negative 2 comma negative 1. That's my vertex. Part D here, easiest part. The y-intercept is just my c value. So 0 comma 3. And now I go ahead and graph. Pull this up just a hair. Okay, first things first is I want to draw my axis of symmetry at x equals 2. So I'm going to draw a dotted line here at x equals 2. Okay, that was pretty good for my tablet. Usually I'm not very good at drawing on my tablet. I know that the vertex point is at 2 comma negative 1. I know that the y-intercept is at 0 comma 3, and then I can reflect, since it's 2 units away here, it's 2 units away here. I see it right there. And I'm only confirmed by the fact that I said that it was going to go face upward. And yeah, I see that here. So round it out at the vertex. Okay, that's not so bad. Let's see how I do the other side. Ooh, not as much. Sorry, drawing on this tablet is not the best. All right, let's take a look at the next one here. So for A, I know that this one is going to go downward. And then here, I know that it's x equals negative b over 2a. So that means negative 2 over 2 times negative 1. So this is negative 2 over negative 2, or positive 1. X equals 1. And then to find my vertex, it's 1 comma something, and I get that 1 right from there. Plug that 1 in. Negative 1 squared plus 2 times 1 minus 1. So this is negative 1 plus 2 minus 1. Negative 1 plus 2 is positive 1 minus 1. Oh, looks like it's 1 comma 0. Part D here, the y-intercept, I believe it's negative 1. Okay, and now I go to graph. Pull that up here. Okay, so we have a dotted line at +1. Oh yeah, that's more like it. Whoa, that was rough. I have to redo that. I am so sorry. Oh my gosh. Okay, there we go. That's good enough. We know that the y-intercept is 0, -1. We know what my vertex point was at 1, and that means I can reflect that over here. And then there we go. There we have it. Okay, and that's my answer. Okay, let's take a look here. Write the quadratic function that the graph represents in vertex form. Remember, vertex form is g of x is equal to a times x minus h squared plus k. So what am I really asking for here? I'm asking you to identify where the vertex is. And then from there, guys, I'm not going to give you one that has a different a value. I'm just telling you right now that this is your treat for watching the video. When I ask you this question on the quiz, don't try to put anything for an a value. That'd be really mean of me to try to give you. And the reason being is it's hard to tell. I think I talked about this when we were doing section 5.1. It's hard to tell if there's been a vertical stretch of compression going on. So how am I going to give that to you? How do I know that there's not one in this case? Look, I go, like, remember I had my axis there. 1, 1, 2, 4, -1, 1, -2, 4. See, it's got the arms are the same. It's not narrower or wider than my original parent. So therefore, I know that there's no vertical stretch or compression that's been applied. But again, I'm not going to give anything to you like that. All I'm really wanting you to do here is identify where the vertex is. Well, it's 1, 2, 3, 4, 5, 6, 1, 2, 3. This is at 6, 3. So that means my g of x is going to be x minus 6 squared plus 3. Remember, your h comma k is your vertex, right? Your h value is your x value vertex, and the k value is the y value of the vertex. Okay, a football kick is modeled by the function h of x is equal to this function, where h is the height ball in feet, and x is the horizontal distance that the ball travels. Find the maximum height of the ball to the nearest foot. Okay, so like if I'm thinking about it here, it's kind of like the problem I gave you at the beginning of the lesson today. So we're saying at 5 feet, maybe it's punted or something. He dropped it. Still kicking it 5 feet off the ground. I'm not sure about that. But anyway, here is the path of the ball, right? I can't use the zeros here because this is not a symmetrical one, right? So I can't use the zeros and take half of it. I need to rely on the negative b over 2a, right? And how do I know that? How do I know I want to find the negative b over 2a? I want to find the maximum height, okay? I want to find the maximum height. When I talk about maximum value, remember we talked about those terms, maximum and minimum, those reference the vertex. That means I want to find negative b over 2a, okay? And then I'll plug that in too, because x is going to tell me the horizontal distance that it's happening. Y is going to tell me the vertical distance that it's happening, and I'm looking for the max height. Okay, so a is negative 0.0075, and b is 0.5. Okay, so it's negative 0.5 divided by 2 times negative 0.0075. Okay, let's figure out what that is. Let's use one of these calculators. 2 times 0.0075. Okay. We know negatives are going to cancel, so I'm going to say 0.5 divided by 0.015. 33 1/3. I'm just going to double check that, make sure I wrote the right numbers. 2 times 0.0075 is 0.015. 0.015. Okay, good. Yeah. Which makes sense, at the horizontal distance, so like 30 feet away, so like 10 yards away, a little more than 10 yards, 11 yards, I guess. 11 yards away, it's reaching its maximum height. I mean, this isn't such a good kick. So
this is 33.3 comma something. Now, how do I figure out what that something is? Well, 0.75 times 33.3, oops, 0.3 squared plus 0.5 times 33.3 plus 5. Okay, I guess I got to go to my calculator here. I thought I was going to be able to get away with that small calculator. Guess not. Okay, negative 0.000075 times 33 1/3 squared plus 0.5 times 33 1/3 plus 5. Okay. Yeah, bad kick. Very bad kick. 13 1/3. 13 1/3 feet. So what's the maximum height? It's about 13 feet. Okay. Where does it happen? It happens at the x value of 33 1/3. All right, let's keep it going. Find the roots of each equation by factoring. Now, I'm going to be very specific on the quiz. If I ask you to find the roots, I'm asking you to find x equals, right? If I ask you to just factor, you do not solve. You leave it as your factored form, okay? So when I say find the roots of the equation, I'm asking you to just give me x equals the numbers. Like, for example, in this one, this is x minus 10, x plus 10. Do not leave it like this. You have to solve for x. Oops, I forgot my equals 0. Add the 10, subtract the 10. So those are my two answers. Okay. This one I got to set it equal to 0. Subtract the 24 over to the other side. Okay, so that means I've got x plus 8, x minus 3. Factors at negative 24 that I had to get to positive 5. That's negative 8 times 3. I'm sorry, positive 8 times negative 3. I want to get to positive 5, not negative 5. So that means we have x plus 8 equals 0, x minus 3 equals 0. So x equals negative 8, x equals positive 3. All right, and now this one here, I factor out the 4x, leaving it an x plus 2. So that means we have 4x equals 0. And now don't forget that is actually a 0, right? That is part of my answer here. A lot of people are just going to let that go away and not make that an answer. That is still an answer. And we say x plus 2 equals 0, so x is equal to negative 2. Okay. Let's try this one. Write a quadratic function in standard form with these two zeros. So remember, that means this is kind of like a work backward problem. I've got x equals 3 and x equals negative 5. So my two factors are x minus 3 and x plus 5. I got my parenthesis going here already. So that means that I have an x minus 3 and an x plus 5 as my two factors. FOIL that out. X times x is x squared. X times 5 is 5x. Negative 3 times x is negative 3x. Negative 3 times positive 5 is a negative 15. So we say x squared plus 2x minus 15. That's my function. All right. Kickball player kicks a ball from ground level with an initial vertical velocity of 24 feet per second. After how many seconds will the ball hit the ground? Okay, so this is just like the one I gave you on the warm-up here, or whatever that first problem was. Negative 16t squared plus 24t plus 0. I want to know when that equals 0 because I want to know when it hits the ground. All right, so let's factor out a negative 8t. Okay. Oh, I don't know, equals. Oops. Negative 8t, that turns into a 2t minus 3 is equal to 0, right? So negative 8t equals 0, 2t minus 3 equals 0,
t equals 0, t equals 1.5. So after how many seconds will the ball hit the ground? 1.5 seconds. Okay, now these factor completely ones. Remember, I do not want to solve for x. I just want to factor down. Okay. So first thing I can see here is that this is all divisible by 2. So let's factor out a 2. We're left with a 10x squared minus 3x minus 4. And now this becomes a hard type factoring where I have to multiply one of those master product ones. I have a negative 40, and I factor it down from negative 40. What would that one be? Oh, 8 times 5. Negative 8 times 5. Right. Leave our 2 on the outside. We have a 10x squared minus 8x plus 5x minus 4. Okay. And then we factor by grouping here. Leave our 2 on the outside. Pull out a 2x. Left with a 5x minus 4. And there's no GCF here other than a 1. So I'd pull out the 1, leaving a 5x minus 4. So my two factors are, don't forget about the 2 outside again. The 2x plus 1 and the 5x minus 4. Could I have said 5x minus 4 first? Of course. But that's my answer there. Don't try to solve for x. That's it. Okay, here's number 16. Look here, I've got a GCF of r squared s squared. And when I remove the r squared s squared, there's 2 left here. No s's. The r's get removed, but the s's, there's 2 left there. And then this, that's a difference of squares. So we get r squared s squared, r minus s, r plus s. Okay. And then our last one here. It's only got 2 terms and there's no GCF, so it better be a difference of squares. And it is. This is an x squared plus 1, x squared minus 1. Notice that this is not a difference of squares, but this one is. So this first stays, and it's not a difference of squares because, well, it's not a difference. Okay. So that first one stays exactly as it is. But the other one factors down into x minus 1, x plus 1, and that's it. Okay. I hope we're all having a good day. I wish you luck on the test, but again, you don't need luck. You've got skill.